No, oh. Morning, if anyone's watching. So we'd finished chapter 5. We'd started looking at loops. If I can get it to load. was weird. Huh. Okay. So we had taken a look at creating a while loop that uses a counter up here. And this would be used for if you want to loop through and complete some task and you know how many times you need to do it. All right. And then this is mostly for console applications, but we have this. Well, actually, it's also used in loops when you're programming games. And that is a while loop that's based on a non-numerical value. And it's called a sentinel value. And you use that to turn the loop on and off. So down here, remember, we were asking the user for input, and then it counted how many times they said anything but stop, and once they say stop, it stops. And we set it up to be that way. Then we talked a little bit about the do while loop. And the main difference here is regardless of whether the condition is true, the loop will run at least one time. Where a normal while loop will check the condition before running. And then we took a look at a for loop to print the numbers between 1 and 99 by 2. Okay, so the for loop syntax can be kind of overwhelming if you haven't, maybe if this is your first programming class. Probably a lot of things are overwhelming. The best thing you can do in this case is learn the different parts, break it down, and then it's easier to understand. Plus you just have to use it. So for example, this part's easy. The proper syntax to create a for loop, you use the keyword for, and then you will put some things in parentheses here after the for loop. So here I'll put it in a comment up here so you can see what the different parts are, so it's easier to break down. So there's the keyword for, and then inside of parentheses you're going to put your counter declaration and starting value. And so here we are declaring a variable called x, and we are assigning the value of 1. That will be where our for loop starts. X will equal the value of 1 when we start. Okay? So that's one piece, and then you use a semicolon here to separate the next part of the for loop, which is your condition. So here is where the for loop will check whether it should continue or not. So true or false. And you can see that down here. For this loop, we had a condition of as long as x is less than 100, it will run the code inside the for loop. So if we start at 1, that is less than 100, this loop will run. But we need the last part here which is how we want to iterate through this. So increment or decrement value. And that's important. Remember, in while loops we talked about something called an infinite loop. As long as we are changing our value in such a way that it will eventually make the condition false, it should stop. If we don't do that, it'll run infinitely, and that'll cause a problem. Usually it'll freeze, it'll lock up the browser or just the web page, or it might even crash it. So you don't want that. Okay, so that's what we talked about last time. Alright, and you guys may have seen this already, but there is something called the increment operator and the decrement operator. So that is this either two pluses or two minuses. In this case, we want to put them after the name of the variable. And what that does is the plus plus adds 1 to the listed variable. Alright, and I showed this in the last video. And the minus minus reduces 1 by 1. Okay. So in this case, we weren't using either of those. We were using x equals x plus 2. So if we use x with the increment operator, instead of going up by 2, here we're going to go up by 1 every time through the loop. And that'll give us each number. Let's see, it says I'm forgetting a curly brace. Or I've got an extra one floating somewhere. Oh, forgot my parenthesis here. There we go. So that gives us 1 to 99. What if we wanted 1 to 100? We could either increase this to 101. And why does this work? Because our condition is testing the value of x against this integer. So the first time through it'll be 1, and then we increment by 1 over here. Let me zoom in, this is kind of small. Okay. There we go. Alright, so we could do it this way. And that would go to 100, or actually we can bring this back over. The problem with doing it this way is now you're using a value just to make it fit, and it's not even, and it's not the number you want. So if we do want to say 1 to 100, we start at 1, and then here, instead of x less than 100, if we want to include 100, we do less than or equal to. All right. So why don't you try and on your own. Okay, here, you know, when you're watching me do this is one thing, but you need to be able to apply this. So why don't you try to create a for loop that will print out all the numbers between 2 and 47. And you want to, why don't you do it increment by 3. So you can pause the video and try that. And then I'll do it here and you can check your work. If you just watch me do it, you aren't going to be able to test what you've learned. And it's okay if you don't do it correctly. So you can identify what part you did wrong, and that will help improve your skills. And then after you try that, think of your own for loop. Pick 2 numbers and try to print out everything between them, and you can try different increment operators. You need to be able to use this, understand how to use this, and be able to do it on your own, because you're going to use this one a lot in a lot of different languages. This one is very important. It might be one of the most important loops to understand. I feel like the while loop is, you guys can probably figure that one out pretty easy. I know a lot of people like to fall back on that one, but it requires a lot more setup and it's a little harder to keep track of. So I'm also going to do, let's just print out 1 to 3 here. Let's see that. Okay, and then after we print out 1 to 3, let's try checking if we can use this variable of x. So I'm going to do console log. And in here, we're going to print out the last number was of the loop and then here we can put x. We'll see if this works, or maybe we'll get an error. What do you think? Okay, it says x is not defined at line 57. So this is illustrating something called variable scope. And in this case, we're not talking about the mouthwash. We're talking about where in your program each piece can only see variables that are within their scope. Okay, and usually you can identify scope by using these curly braces. All right, so in this case, when we declare our x variable and assign 1, we can use that inside of this block of code. Remember, you can think of from the opening curly brace to the closing curly brace as a block of code. All right, we can use it in there, but as soon as the block closes, we can no longer use that variable. So it is said to be within the scope of this for loop. And so when we try to use it down here, it's out of scope, it doesn't know. And we can actually declare a different x variable. Alright, I'm forgetting my semicolons here. let's do it over here. Run. And so here I've set up this value of x, but it only exists within this for loop. As soon as the for loop is done, that x value and that x variable are gone. It frees up the name so we can use it again down here. I don't recommend, in this case, using similar variable names unless it's referring to the same thing, and in this case it's not. So let's use something other than let, because in the book they use var. Okay, let's set it to var and then we'll see what happens. All right. So let's break this down. Zoom in here. Okay, so we had a loop that goes from 1 to 3 and it printed those values out. And it said the last number of the loop was 4. Okay, but it didn't print out 4, right? How did that variable of x become 4? What do you think? So what does the for loop do? And it's not only is it important to understand syntax and understand each individual piece and what it's used for, all right? This will help you label the 3 different parts up here and make sure you understand them. Okay, they have names which are useful to think about and understand in context of other parts of the program and other things that we'll look at in later classes, but they're not very helpful if you don't understand those terms or you're not familiar with them yet. So I'm going to talk about the terms and then we'll actually talk about what they are. So there's 3 parts in the for loop and they're separated by semicolons. Unfortunately, we haven't seen this and we won't see this again for a while, things being organized in this way. It's, for now, we only see this in for loops where each chunk is separated by a semicolon. And what this really is, you know, 3 lines of code. Declare a variable, okay, put a condition to test, and then the increment. Okay, we just put it in 1 line of code up here, makes it more concise, and this is how it's always going to be in each language. All right, we have these 3 parts. So declaring the variable just gives us a starting point and a variable that we can reference, because this is going to change each iteration or repetition through the loop. We've been using conditions since we introduced if statements. All right. So this is a condition. You can also think of it as a test. The computer is going to test the value using this formula. It'll say, is x less than 3? And this, remember, this will always return true or false. And true or false will determine whether the loop continues. Right? And then the last part is the increment, or you can think of it as how much we want to increase or decrease our variable that we declared by. How much are we going to increase it? If we use the increment or decrement operator, it's going to increase or decrease by 1 every time through the loop. Okay, so I put the decrement operator here. Look at it. Remember, it reduces x by 1. How many times do you think this loop will run? And how do you need to be able to look at it and then think about what's going to happen. So let's start. All right, when we hit the for loop, and remember the code here in this case is just run procedurally, which means one line at a time. And so you can read this one line at a time, and then using the context of what's around it, understand what it's trying to do. And this is a very major part of programming, because rarely are you going to start with a blank page and have to fill it in. Usually you're going to have code that's already written by someone else. Hopefully they have time to explain it, or you can ask them questions about specific things, which could save a lot of time. But as you read code more and more, and you become code literate, you'll be able to figure this out on your own. And I just described what all of this does. And so, for example, when I look at something like this, the first thing I look at is, okay, it's a for loop. Ignore what's happening in here for now, and then look right up here, starting at 1. And since the test is x is less than or equal to 3, you can quickly look. It starts at 1, goes to 3, the code runs until the value is greater than 3. Okay. And then I know it's going down by 1. So once the loop starts, it'll set the variable to 1. Okay, 1 is less than or equal to 3. It'll go inside the code here and print out what? The value of x, which is 1. And then once the block is done, it comes back up here. And so with any loop, it's going to go back up to where the loop started, and then except for do while, but don't worry about that for now. It's going to come back up here. It's not going to declare the variable again. That's already happened the first time through. What it's going to do is decrement x. So if I have 1 and I reduce it by 1, what number do I have? 0. Okay. So is 0 less than or equal to 3? Yes. So it'll run the code and it'll print out 0. And then it'll come back, decrement by 1, so lower the value by 1. And when it's doing this, it's actually changing the value in the variable. Okay. So the value in x would be -1 this time through, and that is less than 3. Now, if you're paying attention, you may understand now what problem there is. What's the problem with this? And if you just think about, don't worry about the code inside, just think about how is this going to run. So it's going to start at 1, go to 0, -1, -2, -3. When will it stop? Well, it won't. This is an infinite loop, so we don't want to do that. We want to avoid that. And when you run your code and it locks up, it won't give you errors. The browser may give you an error asking to kill the page, but it's not going to tell you why. So if it locks up, a lot of times it's going to be from an infinite loop. Okay, so if it locks up, you need to check your loops. If you're coding properly, you'll be testing things as you're adding them. And so if you're doing that, you can just check the last loop you added while you're testing it. If I add 70 loops into my code and it locks up, guess how many loops I'm going to have to check? Potentially 70. If you write the whole program and it has and you don't test it as you're going and you run it, you're going to have to check every line. Or if you know how to read the errors, which you should start working on, they're very obtuse. They're technical. So anyway, if you get an infinite loop, you're not going to get an error. You're going to have to manually identify that, because an infinite loop is not a syntax error. We have two kinds of errors that we'll deal with. Syntax errors those are errors you're going to stop making as you learn to program. It's totally fine to make them now. If you make typos, you're going to get a syntax error. If you forget something or put it in the wrong order, the computer is programmed to read this code and it's expecting a certain grammar. It'll tell you if you've confused it. Okay? So those errors are syntax errors, easy to fix, easy to identify, because the computer does it for you. The other type of error is something called a logic error. Right? And these are the worst, because basically what's happened is you've told the computer to do something wrong for solving the problem. And an infinite loop falls under a logic error. So if you tell the computer to run infinitely, it doesn't warn you that you're going to do that. It will just do it. If you tell it to jump off a bridge, it will. Alright? So a logic error is basically a human mistake in the logic. And so if you are writing a program and the numbers don't come out right, you can assume that you have written either a formula incorrectly, or you may have a variable in or out of scope. Alright? Speaking of scope, we have this value of 4 here, but we set up the loop to count 1 to 3. So, did anyone figure out why it says x is 4? Okay. So, running through the loop, what happens when you increment to 3 on this loop? Touchpad here is not cooperating. Alright. So when we get to, once it increments up to 3, 3 is equal to 3. It's less than or equal to 3. So it'll print out 3, and then it comes back up, and remember, the increment happens first, and then the test. So it will change x to 4, which will cause the test to return false, and it won't run this line of code. Now, why is var allowing us to access x outside of the loop? Because that should be outside of scope, right? And if we change it back to let, we'll be able to see that. Okay. So we have var now. Let's change it back to let. Now it says x is not defined out here. Change it to var. Now it says x is defined. So when you declare a variable, and so declaring is giving it a name and creating it, and then initializing is putting in the first value, the initial value. Okay? We're setting this to 1. Here, that's our initial value, so we are initializing this variable. We're also declaring it, because this is the first reference to this variable. If I want to change this or use it again, I don't have to declare it by using var or let. Alright, in JavaScript, var, when you use that, the way it stores the variable is independent of scope in this kind of procedural code. Alright, and when you use let, it is within scope. So the book just has you use var, and there are reasons why you would use both, but moving forward in this programming language and moving into others, other languages restrict the scope. They do not have, at least as as far as I'm aware, they do not have something as simple as var. You would have to declare it as something called a global variable, okay, which is different than what var is doing. JavaScript has, each language has its own little quirks that you have to understand. A few of them you have to understand. If your job requires you to use JavaScript a lot, you will want to learn all the quirks so that you can avoid making errors. So if you use var, you can't guarantee that your variable will be properly used within scope, and that can cause problems inside of your program because it'll be hard to keep track of what variables you have used and haven't used, especially in a large program. This one's tiny, so we can see on the same line, in the same section here, where it is being declared and where it's being used. So I would recommend that you use let, even though we're getting an error here. Again, this is because we aren't properly observing scope, variable scope. And we don't want to use this value outside of the for loop. All right, if we do, the way you would do that is declare a variable outside of the for loop so that it's within the scope of the program, the entire program here. So we're declaring it basically on the highest level of the program. And you know how we indent our code inside of blocks? That helps us identify the scope also. So when I look here in a for loop, it's indented. I know this is going to be a different level of scope. And when it ends, basically that sub-level dissipates or disappears or is gone, goes to the garbage. So I can put ending loop value as a variable name here. All right. In programs where you're going to have a lot of variables, and I haven't really given you guys too much feedback about this, but you really need to think about the variable names you're using. For a for loop, where you're just using it as a counter, using a one letter name is fine, because you're not going to be using this outside of the loop, or you shouldn't be. But if you are keeping the value to use in multiple places in the program, if you don't give it a name that means something, it's going to get very confusing for you to keep track of. So if I want to keep track of this loop's ending loop value, how about I name the variable ending loop value? Or I could even shorten that, because that's kind of a long name, end loop val. I could do that. Okay. And one nice thing about replit is, and I turn this off, so let me turn it back on. Code intelligence. Code intelligence gives you autocomplete, helpful info, and hints as you type. Alright, let's look at what this gives you access to. So I'm kind of showing you guys, now that we've looked at a lot of the most basic parts, once you know if statements and loops and variables and operators, you can do a lot with this. Alright? It's just not very scalable, which means it's good for small things. Larger things will become the code will become unmanageable with this sort of setup, procedural. Okay. Older languages only had procedural code, like COBOL, BASIC probably had it. I never used that, but that was a popular one a long time ago. A lot of people initially learned programming from BASIC, and now it's those are lower level languages also, so they're not as high level as JavaScript or other language. I'm trying to think if you guys have used any other ones. Maybe some of you are in Python. And so a higher level language is closer to human English, usually, and it's easier for humans to understand, and whoever created the language has developed a translator that will convert our high level code all the way down into low level code so that we don't have to think about that part. Alright? So we can focus on creating a solution and not trying to control what the computer is doing to get that solution down at the hardware level or at the operating system level. We can focus on just solving our problem within a vacuum. All right. So with code intelligence, when I start typing the variable name here, hopefully, I might have to reload. Oh, I never turned it on. I turned on infinite loop protection. I never saw that in here before. Well, let's see what that does real quick. Alright, so let's put an infinite loop in here. Let's run it. We'll see how protected we are from infinite loops. Okay. Still running, and you know the code is still running if this little button at the top says stop. That means the code is running. And sometimes, since this is a web-based app, and I'm sure it's connecting to it's constantly saving the code, and so wherever it's saving it to, it's pulling from there when you load it, and then it's probably in the memory of whatever the virtual machine they spin up here. Alright, so I think what it did was stop the browser from crashing or asking you to kill the page, locking up, which is nice. So we know this program shouldn't have taken that long to run. So after a while, you can kind of guess, hey, maybe something's wrong. There's always a reason why the computer does something. Okay, now it's asking me to kill the page. So I'll wait since I've stopped it anyway. Alright, so we'll fix that, make sure it's working. Not a good sign. Okay. It's probably still running that loop in the background, so I'm just going to refresh. And it takes the browser a little while when you have an infinite loop to fix here. Alright, let's go back. I don't know why I have two of these open. Okay. Turn that loop protection off and make sure we have code intelligence on. Maybe we can get it to work. There we go. Good. I was worried there for a second. Let's go ahead and zoom in a bit. I think maybe, okay, font size to large. Let's change it to huge. There we go. Oh, but you can't change that code, the size in the console there. Is it printing out in this console? So, if you're not using Replit for something and you're using Notepad, remember, do your code in Replit to turn it in. But if you do use a different text editor, I recommend Visual Studio Code. It's free and has a lot of features. Anyway, when you're in the browser and you want to see console output, you hit F12 to open this panel. And at the top, Elements will show you how the page is built in this top part, and then it shows you the CSS in the bottom. We're not concerned with that in this class right now. When we start manipulating the web page, it's useful to look at, the code of the HTML to see exactly what the JavaScript is doing if you're getting errors. Okay. Anyway, you can just hit console up here, and we've got all kinds of errors here. But at the top, here's our lines. One. Can I zoom in on this? I don't think so. Okay. You're going to have to imagine it. Up here at the top, it's 1, 2, 3, and then the error, because we have a variable out of scope, or we don't have a value inside of end loop val, because we declared it here, and then, like I said, if you want to get a value out of your loop, you need to store it in a different variable. So I can do x equals, for x assigned to the value of x, end loop val, assign the value of x there. Now, in this case, every iteration of the loop is going to change the value of end loop val, but we really only care about the last value. So it is doing some extra operations here. This is inefficient, but it's just for a demonstration. Alright, so if we're using let, I never finished the name here. Got distracted. Okay. So now it's counting 1, 2, 3, and so in the last iteration, when the value of x is 3, it's assigning that 3 to end loop val. And so that if we're keeping variables in scope, which I recommend because you're going to have to do it in the future languages that we look at, you can pull that value out by storing it in a different variable. And remember, this variable, we are declaring it with let, so that means it's within the scope. Here in this case, it's within the highest scope, which means lower levels of scope, like this for loop, can see it and change it, but the values that are defined within this lower level are not, do not have persistence. They're gone when this block is done. But end loop value is not, because it's declared at the higher scope. Alright, I'm repeating myself a lot here because these are very important things to understand. So the people that understand this, sorry, but everyone needs to make sure they're clear on this. If you taught yourself programming by trial and error, there's a lot of these things you may not know. If you read textbooks, you have to be very thorough, and it's difficult to read a textbook for, I think, most people. If you watch tutorials, they're not always the best, and you never know, if they're focusing on one thing or another. So you could probably identify a lot of differences between different tutorials. Like mine, for example. In this case, I'm going extremely slow, and I'm being thorough, trying to describe everything that you're seeing. Repetition is a good way to get things to stick in your mind. though unfortunately repetition in a short time does not work as effectively as over long periods of time. So if you really want to memorize this, which some of the basics and how this stuff works, you will memorize with practice. That's why you have to do the same things a lot of times in these exercises. Every time you think about it, it's going to make it stronger in your mind. Okay. So if you do it once, you might as well have not done it, unless you have a really good memory. Because as soon as the class is over, if you go to watch Netflix, you're going to forget what we talked about until you get to the homework. And then maybe if you do the homework after the lesson, it's fresh in your mind and you're hitting that memory again. And it's an effective way to learn. A lot of people don't realize that. Okay. And plus, listening to me for so long probably makes you want to do something else after the video. Anyway, okay. So remember, I turned on code. Yours should be on code intelligence. That should be on by default for you. I turned it off because it was bothering me. So I type end, and it shows me here, because I've declared this previously in the program, it shows me end loop val. And if I just type E even, it shows me that. That's because there's only one variable in here that starts with E. If I have let E equal 1, okay, if I type in E, it still shows me that. Here, let me see if this helps. Okay, E. Let me reload here. I wonder if it's because end loop is declared first. So this code intelligence has nothing to do with JavaScript or the code. It's part of the text editor. Okay. Specifically, this one is Replit. Replit's text editor. And now, this was something that really confused people before, but if you have a smartphone and you send messages, your smartphone does this now. It's autocomplete, right? I think maybe I need to make it longer. There we go. So I'm testing out how this works. So you type a letter or string of letters. The code intelligence will list the variables that match that for you, and you can press up and down on the arrow keys to select one, and you can hit tab, and you don't have to type it. So if I go down E, down, okay, you can type quickly and it will help you remember your variable names. Alright, a lot of you guys are probably already using that. Maybe you didn't realize you could hit tab to finish it. Maybe some of you guys are clicking on it. If you can learn shortcuts that minimize the time or anything that requires you to move your hand over to the mouse and then back to the keyboard, you lose a lot of time doing that. So if you can learn the shortcuts, you're going to be more efficient. Okay, that's something that also comes with practice. When you code a lot, the typing is part of the worst part of coding. So coders know this, programmers know this, so they create all these tools to help speed it up. I was going to show you can also click on it for people that may not be comfortable with the shortcut yet. All right. I think I've done this in previous videos, but I didn't explain it. Again, this is part of the text editor, but if you want to comment out multiple lines of code, you hold Control and you do /. Okay? The / starts in the bottom left and goes to the top right. Okay? That's a /. That is in the bottom right of your keyboard, should be to the left of your right shift. All right, if I wasn't using, oh well. It's this one right here. Understanding the names of the characters on the keyboard is important for programming. Understanding the difference between / and / are important. So let's see. Okay, / is above the enter key. Right here. So there's the enter key. Here's /. We use the / for escape characters and strings. So if you want to insert extra lines in your code or your output, you can just throw some \ns in there, and you can note it. You may notice the code for an escape character changes colors. Okay, \n, the computer does not see that as two characters. It sees it as a code that means insert a return here. So if I run this, you can see now it's pushing this down to a new line where I put the escape character. Here I'm also doing that, so it's putting that down here. All right, and I saw some of you guys using the tab, which is a good one for making like a table output in a console program. All right, so here's some tabs. Helps you line things up, just like in Microsoft Word. All right. Now, console programs like this have their uses. They don't have graphical user interface overhead, so they can run a little quicker. And but you're limited to characters down here. You could do some Ascii art though. So if you do like oops, let's do this. Change these to new lines. So back when when everything was a console and everything was characters, people would design artwork using characters to help illustrate certain things. Commonly referred to as Ascii art. And let's do one more. We'll go. Alright. So I can make a little thing like this. I'm not sure why this is. Oh, I have a space here, that's why. And here. So, not the best, but it's kind of cool if you want to look at some better Ascii art. So these images here, these are made of characters. Someone could have wrote a program. It's kind of like a mosaic, basically. So you put a bunch of similar things together in different orders to make a picture. So here's an R2-D2, and as we zoom in on the R2-D2, maybe it'll let us zoom in. You can see it's made of hashtags, periods. We've got some semicolons, plus signs, and that allows you to create kind of a contrast using white space. And as you zoom out, you can see it, but if you zoom in, it doesn't look like anything. Mosaic art. So, you know, people have written programs where you can input an image and it will approximate Ascii art versions of it. So let's see if we can do, oh, the cool ones are photo mosaic. Alright, so that's not one. We've got some up here. Here's a nice one of a, I guess an elderly couple. All right. And if you zoom in, you can see it looks like they made this art using a bunch of family photos here. And if you zoom in, you can see each individual photo, but if you zoom out, oops, zoom out, let's go back to when it was smaller over here. It just looks it just looks grainy a bit, but it looks like they it sorts the photos in certain orders so it can approximate colors and things. All right, anyway, since we're using console programs in this initial part here, you are also asked to use document.write. So let's take a look at that. And so this is really what you're going to be using JavaScript for, is to manipulate a web page. And so when you do console.write, this is going to go right into the HTML of the web page. So if I do console.write, and I throw this in here, and get rid of my extra, oh, it did it for me. No, it didn't. Okay, get rid of this extra here. All right, just printing that out here. Oops, not console.write. What is it? Document.write, right? Okay, lots of things to keep track of. It's putting it up here. Now, I did put escape characters here for line return. Why is that not reflecting in the HTML code up here? What do you think that is? Well, we can check if we had F12, check in the panel here, and we don't care about the console for this. We want to look at the elements on the page, because that's where we're putting the result of this code. And unfortunately, if you're doing this in Replit, we don't want to do it in here. What we want to do is open it in a new tab. So you hit the little button in the top right over here. It's a box with an arrow facing to the top right. It says, when you highlight over it, says open in a new tab. Click that. It opens just the web page in a new tab, so you don't have the rest of Replit in your way. So there it is. It's all on one line, but we don't want it all on one line. So let's look and see. All right. Here is what the JavaScript put on the page. And it is those 3 lines, and they are on separate lines. But if you remember, if you're in 099, or if you took 099, Intro to Web Tech, where we learned about HTML, you'll know HTML ignores white space, which includes spaces, tabs, returns. HTML does look at the first space after a character and uses that, but after that it ignores them. So if we want to get this on 3 lines in HTML, we have to use the element that puts it on 3 different lines. So we can go back, and I think the book shows you this. They do it in a kind of a weird way where you declare it as a variable. So we can do let new, well, I guess they were just doing BR, which is the line break element. I'll call mine, we can't use the word return, so I'm going to call it new line. So I know what it is, and it makes sense. Okay, and then what is the element for a line break? It is BR. We have to include the angle brackets because this is HTML, and we want it to be interpreted as HTML. All right, sometimes you'll see BR by itself. Sometimes you'll see it with a space and a slash. Why does it do that? Or why are there different ones? It works both ways. Older browsers can only see it if you do it this way. So depends on what audience you want to see this. I usually do it this way because it's shorter, but you know, if it's something for a business that wants to maximize who can access the site, you know, people around the world may have older phones. Maybe some people still use flip phones. Sometimes the browsers aren't the most up to date on those. So you can add that if you want. I'm going to go ahead and leave it in there this time. And instead of line breaks here, or I'm sorry, the escape character for new line, I will concatenate in that variable. And let's give us some space so we can see what that looks like. New line, so I'm going to type new tab. And so here, when you're concatenating strings like this, it can be a little tricky because you have to use a lot of symbols, right? So anything with double quotes around it like this is called a string literal. So it's not a variable, it is this value and only this value. It is literally that value. Here, and then if I want to concatenate or combine that, stick the two strings together, I have to put a plus between them. All right, and you're going to see this. Most of the languages, pretty much all the languages, we're going to use the string concatenation this way with the plus sign. All right, there are some better ways to do it that we'll look at, but this sticks two strings together. If I don't have this, it's confused about what I'm trying to do because I'm not using the proper grammar. This is a syntax error. Okay, so that'll push it down a new line in HTML. And then we're going to add a string literal to that. So we need to concatenate with the plus sign. And then it'll put that in. We do the same thing. So you have to add all these pluses and double quotes to build the string. And if we run it, we can see now it's on 3 separate lines. And so the output in the console can use escape characters. And if you use escape characters in your HTML, you cannot, it won't go to the next line unless you use the proper HTML element. So you have to understand where your code is being interpreted and how it's going to be read. Now I believe there is an element in HTML. Let me test this out here. It can save you some time. If you're pulling, for example, you may be pulling a block of text from somewhere else, data from another site, from a database or something, and it may be formatted not in a way that's not the best for HTML. And there's a few different ways you can handle that. Let me see if I remember this right. So if you do pre, I'm going to pre this. All right, inside of here, I believe, okay, this is why I turn code intelligence off sometimes. If you don't want to use what it's recommending, you can just ignore it. I don't know why I was hitting tab. Okay, but I was hitting enter. So if I want to hit enter after this, it's going to choose turn it into an element because I'm in HTML. If you don't want to do that and you want to hit enter, you just hit escape first, then hit enter. All right, now let's load this in a new page. Okay. Whoop. And look, the HTML did not ignore the white space. So you can use this pre element. You can pre your elements so that they will show up. Now unfortunately it did include my indents here, so if I want this to be left aligned, in the page. I got to move it out of the indentations. Okay, and I can do that. So if you pull a block of text from somewhere, you can use escape characters in there. So let's get rid of this, and this will let's do, how can we do this? What's the best way to do this? We can have new line, we can have pre-start, and we can do pre. And there's a better way to do this, but we can't do it until we get functions, so we won't worry about that for now. Hopefully that's the next chapter, because that adds a lot of control to your program and it makes it a lot more scalable. You don't have to repeat yourself as often. So opening, so we're going to start pre, and then we're going to end pre. That would have been a better name. Pre-start and pre-end is fine though. Okay, and so let's get rid of this, because we don't need to include those new lines in there. So if we want to build a string using escape characters, we can do, start with our pre-start, and then make sure we end with our pre-end, and then we can minimize the symbols we have to use to format this. Okay, we can move this in here. Okay, let's make sure this works. Alright, so I'm not using line breaks anymore, and I'm still getting the output that I want. It's recognizing that white space. Okay, so use that as you will. Little tip for you. Makes the strings less confusing. Let's try looking at something, because I haven't done this in JavaScript, because I really haven't had a need. Okay, we got template strings. Let's see if this is something useful. Okay, so to use this, we need another character on the keyboard that you're probably not familiar with. So let me get that and I'll show you. Programming languages really make use of a lot of these symbols to mean certain things, shortcuts in the code, or things that, they use the characters that aren't normally used. So right here on the keyboard, for mine's right above the tab, should be under your escape key somewhere. It's called, it has two things on it. It has the tilde at the top. Some people call it tilde, tilde, tilde. It's all the same. People just pronounce it differently. People don't talk about it all the time, so most people. In the bottom is something called the backtick. Okay, so we got a squiggly line, and then what looks like a backwards single quote. All right. And so all right, I did not hold that up very well, but oh well. I had to go back to my worst camera. No, I'm on the good one. Okay, anyway, it's not focusing up close, so let's see. Here it says if you enclose a string in backticks, you can use your variable names and code right in the string by enclosing it in brackets and starting with a $sign. So let me show you this. And this is great because this is the ultimate way to kind of reduce the clutter, the symbol clutter in here. So I'm going to put don't put a single quote. it's I reached over there to hit it myself, but I want a backtick. So I put a backtick here, and I'll put a backtick at the end. And so I don't need double quotes anymore, and I don't need these plus signs. Okay. I don't need this plus sign here, or this double quote. Alright. I don't need this plus sign, but I do need to specify which ones are variables by putting them in square brackets, or I'm sorry, curly brackets. And in Replit, again, this is part of the text editor. This has nothing to do with JavaScript. You can select a word, and you can double click to select a word. It's not as good unless it has the proper separators. So I have end loop val here. If I put square brackets, it'll put it in square brackets. If I put it in quotes, if I put it in backticks, you see how it's putting them on both sides? That can save you a lot of time because you can just go in, double click something, and then surround it with the right symbols. So this is a variable, so we put a $sign right there. All right. And we have two variables over here, so I want to put them in curly braces. Okay. And start with the opening one, or it'll give you problems. Okay. And make sure you put $sign in front of it. Okay, let's see if this works. Nothing should change if this works. Okay. Okay, I forgot to close something on line 63. Parenthesis goes to the end. That goes there. That goes there. Let's double check the syntax. And so this is JavaScript documentation website. Default function, if there's an expression. Okay. Okay, I was looking at the wrong thing. We want expression interpolation. Okay. In order to embed expressions within normal strings, so a variable is an expression, any variables with operators or literals and operators, it's an expression. It'll evaluate to some sort of value which will be turned into a string. So I'll need more time to look at this because I haven't used it before. I thought it would be simpler than this. That's probably why the book doesn't include it. Alright, so let's not worry about that. Let's go back to the one that worked, which was this one. Okay, and then here undo is really useful, Control Z. But if you go too far back, like I just did, you can do redo. And this works in most Microsoft programs as well, like Word, Excel, PowerPoint, a lot of text editors, which is useful. You can hit Control Y to redo. So you can kind of see the steps you made to build something. So I can go back, see what things were, and then if I press Control Y, I can go back forward. And so if I go back and I type something, it will erase the future steps. So be careful if you're using redo and undo that you get it to the way you want, because if you continue from there, you can't go back forward anymore. So let me get rid of that stuff in there, and then I'll type hello. Okay, and then if I hit Control Y to redo, it's gone. If I go back, I can go back further, but if I go forward, it brings me to hello. So be careful about that. Also, if you're trying to get something to work, I've seen a lot of you guys do this in your work. You try it the way you think it works, okay? And then from there, you edit it, and by the time it becomes a mess, and then you get it's frustrating when it doesn't do what you want, okay? But you'll get little pieces in there. I had someone trying to do, they had it right. They had it, there were two ways to do it. They had it right both ways, but they were trying to do both. And so don't forget, you can comment out certain lines. And the reason I recommend that is you can keep them there, and they won't be used by they won't be interpreted, and so none of that code will run. But if I cut it or I delete it, and I want that back, I'm gonna have to rewrite it. And so at this point where you guys are at, that means, going back to a reference in the book or Googling it, maybe looking at a previous assignment, but you can save yourself a lot of time by just commenting it out. And then you can leave these comments in there, and once the program works the way you want, you can just delete them, or you can leave them in there. Letting me see what you were trying can only help when giving feedback. But if you don't want me to comment on it, then delete it. Okay. So let's take a look here. What do we have? Okay, it is the 19th. You've got this paper towels program to work on, and you have the rain bucket to work on. Okay. Next Monday, we will go into chapter 6. And no, we just did chapter 6. We'll go into chapter 7. And let's see. Complex conditions. Okay, so we're going to learn about logical operators, and you can do some really cool stuff with this. If any of you were electricians or worked with electronics before, this will be very familiar to you, because programming is based on circuitry. It's just following logic pathways. So you have AND gates, OR gates, and hopefully I'll remember this for next time, but we can look at circuit simulator. Alright. No, we don't want an we can, this one's a little complicated. Let's look at, this is for electricity, but we just want logic gates. So we can do logic gate simulator. Okay, and this chapter really is what this class is about, logic, right? And everything that you're going to be using a computer for is based on this at the lowest level. Here we go. Okay, I think I've seen this site before. It's pretty cool. So we can use And you may have heard these terms before, and or. Okay. I'll put an and in here. Let's put an or in here, and I'll definitely use this for the demonstration for this, because visually it makes a ton of sense. Okay, so let's put a light bulb here, and let's put a light bulb here, and so inside of a computer, these light bulbs would be transistors, and we'll have this clock represents the CPU because it works in pulses. So see how it's pulsing, it's sending a signal. Okay, you could also have a constant signal. So let's use that actually. Okay, well, I'll just leave that floating there. Oh, we can have a switch. So we'll do constant for here, a constant for here. Okay, constant and constant. And we'll put a switch. Let's see. Yeah, let's use switches. Hopefully these, okay, they turn blue when they're on. So when the switch is off, this can be a 0. When the switch is on, that's a 1. When the switch is off, that's false. When the switch is on, that's true. Okay. Let's put a couple of switches here. Put a couple of switches here. Ignore all this stuff out here. There we go. Get rid of that. It's distracting. Okay, and then we can connect the circuit here. All right. Connect it to the light. Alright, so it's kind of a bummer this isn't labeled. Can I put a text box in here? No. Okay, well, we'll just have to know here. This is the and, this is the or, and we can test that. So we're going to look at how to use and or in our conditional statements, like if statements and even loops, right? Remember, they use a conditional expression. So here we have false, and the light's off. I'll turn one switch on, so we have true and false. The light's off. Now let's do true and true. The bulb is on. So if we want to check if two conditions have to be true for our if statement, we only want to be true if two conditions are true, we use and. So if either of them are false, or both are false, it's not going to light up. The code is not, the light bulb lights up, that means the code's going to run. Okay? And the or, this is the or. Alright? We have one on, or we have both off, it's off. Okay? That's easy to remember, it's the same. If they're all off, they're both going to be off with these that we're using. Some of these other ones are weird. Okay. But we only worry about and or. Okay? So, with or, first one on, lights up. Second one on, lights up. What do you think both will do? Because both on the and lit up. What do you think both on the or is going to do? And you can just say this out loud, logically. And think of a condition other than an or gate. So an or gate could represent something like, I'm terrible at thinking of these off the spot. Okay, here we go. You go to the grocery store, and they ask you cash or card. Okay? What does that mean? What does that mean? It's cash or card. Are they going to let you buy it if you have cash? Yes. Are they going to let you buy it if you have a card? Yes. Are they going to let you buy it if you have both? Yes. Are they going to let you buy it if you don't have a credit card or a debit card and you don't have cash? No. So that's a situation that would represent an OR gate. And we can use the same example here. Let's say you only have your debit card. Will you buy it if you have your debit card but you forgot your PIN? No. You need both. So this would be an and. You need your credit card or debit card and your PIN. I guess you only need your PIN for debit cards though, right? So it really helps if you use an example that's logical, because when you start mixing NOT gates in there, which we do, right? Can I just take this off? Can I click it and delete? Okay. So what this does is if it doesn't get a signal, it sends a signal. If it gets a signal, it stops the signal. Okay? And we did look at the not equals operator. That's what this is. Okay? So look, I have, for the and, they're both off. It lights up because we're turning it to the opposite right here. So how do I turn this one off? And this one, they're both off, it's lit up. If I have one on, or both on, it's off. So it's doing the opposite of what we were doing before. And so coming up with an example of this is even more difficult. So it kind of reverses. This is kind of like true now, right? Except it doesn't work when they're both on. And it doesn't work if just one. And then so here, if you want to test if two things are false and then run the code, they both need to be, if you want to see, if you want it to run if one of the things or both are false, use an and then a not. Okay, anyway, next time we'll take a look at this in the code, and we'll keep this as an example. So I'll show you what the circuit looks like, and we'll look at how we represent that in code. And I'm telling you, this right here is the lowest level in a piece of hardware. So your computer is full of an insane amount of these, okay? Especially the CPU. It has all these different gates. It has all of these, it has the CPU clock that pulses signals through. And we'll take a look at that too. And it has transistors to store charges. And those control other gates. And you can make these very complicated, even to the point, let's see, I think they might have some templates on here. You could build a computer on this. And I don't have one on there, let's see. But I think you can save these and share them too. If you understand this, it helps you so much understanding programming. So let's look at computer circuit simulation. This might be the one that has, yeah, I think this one has, no, I can't see it. Here we go, samples. So we can go down here. There's a whole bunch of different type of circuitry that are combined together to form certain things. it's good to understand it on a basic level, especially for building your conditions and if statements, but you don't, unless you're actually building hardware or designing hardware, you don't need to worry about this kind of circuitry, or if you're wiring your house. So here we go. This is a 4-bit CPU, so that means it can store 4 values of true or false. All right, and you'll see how big and complicated this is. So here's our here's the read-only memory, and here's our input. Here's the output. So we can change this to a 1 and send a signal through to let that go through the gates. My touchpad will cooperate. No, okay. There's probably another button here. But anyway, we'll just look. You can see this is the circuitry that's required to have a oh, we only have that one input on, that's why. To have a 4-bit CPU. Alright, come on, touchpad. You got this. There we go. Okay, so let's do 1 and 1. Choose the operator. Oh, here we go. We're not sending a signal. Let's do, there we go. Constant signal. Or no, here's constant signal. This is shooting the signal through from the CPU. Okay, now we can do it. So you could theoretically build this yourself. If you could, or if you learned and did it, this is the lowest level of programming. This is what people did. This is probably what, Bill Gates and Steve Wozniak were working with to create their own hardware to run code. Alright, so it looks like we don't want that because that's messing up the numbers. We want to send one signal through. So let's turn that on. Nope. Alright. Okay. Anyway, I'll probably have to look up how to use this, but we don't need to look at this again because all I want you to see is, this is simulating a computer. You could get these physical pieces. Get some wires, get some switches, get a battery, and get some light bulbs. Hook the battery up just like we did here. Oops, not that one, this one. Okay. Hit those switches so the signal can go through and through those gates, and the light bulbs will light up just like this. Put enough of those switches, gates, and light bulbs together, and you can have a computer. All right? It's just going to be huge. Oh wait, we want the CPU. CPU built with circuitry. I mean, it's all using circuitry, but I'm trying to see if anyone built a large one. Yeah, I know some of you might be fans of Minecraft. This is the same thing as like the redstone blocks and wires. Probably fewer of you have heard of or played Factorio. You can set up this kind of stuff in there. If you know what you're doing, you can make a lot of different things. Here we go. So, do we have a picture? Here's a physical version of an 8-bit computer. And so it's just wires. These are the gates. They labeled it with pieces of paper because it's a kind of a mess physically. And so this is 8 bits. And look how much space it takes up. So it can represent values, I'm going to assume. With 4 bits, you can do 2 plus 4 plus 8 plus 16. Or, I'm sorry, 1 plus 2 plus 4 plus 8. So that's 12. Plus 3 is 15. So you can represent the numbers 0 through 14 with an 8-bit computer or an 8-bit CPU. So you can't do much with that. Right. Let's look at bits in modern CPU. Okay. Most modern processors are 64-bit, which means that the size of each data value is 64 bits. So let's look up highest number represented. Well, I think we can just do 64-bit number. So a 64-bit number goes from negative this number, and that's too many groups of 3s, so it's more than a million, more than a billion, more than a trillion, and then at that point my memory gets fuzzy on what this is, because how often in the real world do you work with numbers like this, right? If you are doing biology or chemistry or a lot of science, you may work with numbers like this, but in your day-to-day, you can't even imagine this many numbers. It's impossible. It's hard enough to imagine a million. Okay, try to imagine actually a million things all at once. Alright. Don't melt your brain, though. So an 8-bit can go from 0 to 255. So you're very limited there. Alright. So now you know why, if you're a fan of Nintendo, the NES was 8-bit, and that's why it looked the way it did. The Super Nintendo was 16, is that right? And then Nintendo 64, 64-bit, wasn't it? Let's see. Yeah, it had a 64-bit processor. Why don't we go to higher bits? Well, I'm not sure if we need numbers that big. If maybe you have a supercomputer or something, you can have customized hardware. For most people, those numbers are fine. Let's see, 64. If you get into computer science, you have to memorize and understand all of these number limitations so you can apply them, because if you use a number that uses the larger range, it's going to take up more space even with a lower value. You have a lot of zeros if you put the number 1 with a 64-bit number, it's a lot of zeros and a 1 at the end. If you do an 8-bit number in 0, there's only 7 zeros and a 1 at the end. With 64, there's 63 zeros and a 1 at the end. So it takes up more space. Let's see. I forgot what I was looking up here. 64-bit. Oh, float. .64-bit float limit. Represent integers of a value less than or equal to 2 to the 53rd. So, if you see this, you know, depending on your math experience, you may have seen this or you may have not. What this means is this number here times 10 to the 15th, so you're adding 15 zeros on the end. You're moving this decimal place 15 spaces to the right. And so that would take up a lot of space. So if you have a bunch of extra digits, you know, as you go farther, depending on what you're doing, as you go farther away from the decimal here, and again, this is something that's hard to imagine. It's easy to imagine tenths. Take a cake, cut it into 10 slices, equal slices, that's a tenth. Hundredths, cut a cake into 100 pieces. Cut a cake into 1,000 pieces. Cut a cake into 10,000 pieces. Okay? Every number cutting into smaller pieces. At a certain point, you know, cut me 1/1000th of the cake. If it's a normal size cake, that's an insignificant amount of cake. That's like a crumb that fell off. I'm just going to throw that away unless you lick the plate. All right. And so after here, those numbers are so small. In that example of cake, it doesn't make any sense. But again, if you are working with, you know, very specific scientific data, you want to preserve those. And we're not, so we don't worry about that. Anyway, a little bit of background, what we're doing, setting us up for chapter 7. All right, so if you have questions, email me. If not, I will see you next Monday.